All right, what's happening, my mathletes? That's right, Mr. Muscarella coming at you. And in this video, we are going to take a look at reviewing inverse trig functions. And we will use that to find, anytime we're working with inverse trig, we're trying to find the number of degrees in an angle. Because the angle is the part that is unknown and not the side. So when we look at these, you'll see question marks in a space that is denoted by an angle. So we're trying to find an angle measurement here. And that's what we need to do. So couple things on this. When we take a look at triangles, the three basic trig functions, we're going to have sine, we're going to have cosine, and we're going to have tangent. So those are the big three trig functions that most everybody looks at in geometry. So let's take a look at this first example right here. And when we look at the values around this triangle, I have two sides. So when I have two sides, I want to label the sides based on where this angle is. And sometimes we'll see a question mark here. In other diagrams, it might be a Greek letter. It might be something else. So it doesn't matter what the variable is. Just know that it's an unknown. So based on where this angle is, this over here, 13, that side is opposite. And then the side that where the 33 is, that side is across from the right angle, so that means that will be the hypotenuse. And of these three trig functions, the one that has to do with opposite and hypotenuse is sine. So when I go to work with this, there's going to be kind of a couple things here that we will work with. Now, I'm trying to find the angle, and I know that the sine of this angle, we're just going to keep it as question mark. Sometimes it'll be a theta. So the sine of this angle is going to be this ratio of 13 over 33. Now to find the number of degrees in this angle, we have to use the inverse sine function, or arcsine. Now some textbooks will write this. They'll write arcsine. They'll write the whole thing out. Other textbooks will simply write sine with an exponent that looks like a -1. So both of those mean the same thing. So make sure when you're communicating, you don't just say sine to the -1 power, because that's incorrect. You want to say arcsine. So whichever form that it's in, whether it's all letters or the word sine with the exponent, you say the term correctly, which is arcsine. So with that said, let's go ahead and figure out what our question mark is. So our question mark is going to be the arcsine. So we'd have sine, we'd write a little exponent of -1, and then our fraction goes in here. Now from here, we're going to use a graphing calculator or Desmos to check that. Now, key point right here, because we're working with degrees, so big key idea, we got to make sure things are set in degree mode, because if they're not, then we're going to get an incorrect answer. And I think on this one, what do we have to do? Round it to the nearest degree. So we got to figure out how many, is it 10 degrees, 12 degrees, 50 degrees, however many degrees it is we're going to do that to the nearest degree. So when we do that, we're going to have our question mark, because that represents our angle, is about. Now we're going to go to a graphing calculator first. So let's go ahead and take a look at that. Now, just a quick review to make sure you're in degree mode, hit the mode button. And then there we go. So we want to make sure our calculator is set on degree. Now here we had the fraction of 13 over 33. So to get to arcsine, it is right above the sine button. So you have to hit the second key first. So we'll go to the home screen. So hit second and then mode. Now to get to arcsine again, hit second and then sine. And that gives us arcsine. And then we just type in the fraction, which was 13 over 33. So you type in the 1/3 over and divided by 33, and then you hit the parentheses, close that off. It's very important to make sure you close the bracket off, the brace off there, the parentheses. We get 23.199. So that is about 23 degrees. So we would say angle measurement of about 23, and we put the little degree symbol to notate that. Now if we're in Desmos, so let's go ahead and go to Desmos. And from here, if we were to type that in, we would just simply, so there's a couple different ways to get to the sine function. One of them is actually over here on this functions button. So hit that keyboard, it's in the lower left-hand corner. Hit the functions, and you'll notice the trig functions are all right there. So arcsine, boom, is right there. And then you just type in 13 divided by 33. And when we first get that, notice we get 23.1999999, and I want to check to make sure I'm in degree mode. So right over here, when we hit that wrench, then go down to degrees, we want to make sure that we are in degree mode. Because if we're in radian mode, see how we change that there back to radian mode? 13/33 gives us a completely different decimal value. So you do want to make sure you are in degree mode in Desmos as well. Now here in Desmos, we've got it set up as a fraction, which is really nice. In our TI-84 graphing calculator, if you want that to look like a fraction, so you have to have an operating system that's up to date, and you could do that by the following piece when we take a look at that. So you could do arcsine, so you would type that in again, but then this time hit the alpha key and the y equals. And if this menu does not pop up, that means your operating system is not up to date. So see your math teacher or find a way to get your operating system updated. Because when we hit enter and then type in 13 and then put 33 on the bottom, again, don't forget to close parentheses, boom, hit enter, we would get the same thing. So whether you use Desmos or your graphing calculator, you should get the same values, 23.1998, blah, blah, blah. And we got to go to the nearest degree, so that would round to 23 degrees. So that's how we would write that. Now, again, you'd get 1 point for setting it up, now, and then 1 point for rounding the answer correctly. So your setup is 1 point, and then this piece is going to be another point here. So this would be worth 3 points altogether. And that's for example number 9. That's for example number 10. Now with example number 10, a little bit different here. So on example number 10, we have got all three sides. So we really have some options here as far as how to solve this one. So based on where this angle is over here, so the 9 is opposite, the 40 is my adjacent, and the 41 is the hypotenuse. So I've got three sides, which means I could use any of the three trig ratios. So whether I use to figure out the value of the missing angle, so that missing angle could be arcsine. So I could use arcsine, and then the ratio that I would use for arcsine, that's opposite, which is 9, hypotenuse, which is 41. That could be one option that I could use. Another option, say I wanted to use arc cosine. So instead, so my angle theta would be equal to arc cosine, so you'd get cosine with that little -1, and then my ratio for cosine is adjacent over hypotenuse, so that'd be 40/41. I could also use arctangent. So that could be my other possibility here with that. So I could use arctangent. So if I use arctangent, then that would end up being set up like this. So that angle would be arctangent of the ratio for tangent is opposite over adjacent, which would be the fraction 9/40. So either way I slice that, I should get the same answer. So I want you to take a moment, hit pause, and whether you're using your graphing calculator or Desmos, go ahead and let's see the values that you came up with. So you can see no matter which way we slice this or dice this, we get the same values for that. So again, make sure you're in degree mode in both situations, whether you're using Desmos or you are using your graphing calculator. So this one, and again, I think this had to go to the nearest degree. Yeah, so with each one of these, and this is again a notation thing right here, so our angle would be approximately, because it's not the exact angle, it's an approximation. So in each case, to the nearest degree, this would be about, and what were our values again? 12.68, so that would round to about 13 degrees. Lucky number 13, so put the number 13, and don't forget to add your unit, which in this case is degrees. So that's how you do number 9 and number 10. So finding measures of indicated angles using inverse trig. And remember, inverse trig, the variable is going to be the unknown angle. So that's what's a little bit different compared to other problems where the unknown value, like the last one, was a side. So that's where you just use regular sine, cosine, or tangent. And by regular, meaning not arcsine, or cosine, or arcotangent. All right, that's it for this one. Thank you guys so much for watching. And as always, make it a great day. And I'll catch up with you later. Peace out, Cub Scouts.